Today's question is about uniform circular motion. Now, part A, state 3 factors that affect centripetal force. Before we state the 3 factors, let's consider this. Force is given as mass times acceleration, and for this case, we'll talk about centripetal force equals mass times centripetal acceleration, where omega squared r is the centripetal acceleration, omega is the angular velocity, r is the radius of the circular path, and m is the mass of the body. We can also give the centripetal force in terms of the linear velocity, that is, centripetal force is mass times velocity squared over r, and velocity squared over r here is the centripetal acceleration. Now from these, we can therefore state the 3 factors that affect centripetal force, and those are angular velocity or linear velocity, that is omega of or r. We can also talk about radius of the circular path and mass of the body, just as we've had r and m. Now for part B, a mass of 0.4 kilograms is rotated by a string at a constant speed v in a vertical circle of radius 1 meter. The minimum tension in the string is 6 newtons. Then Roman 1, indicate on the figure below the position of the object for minimum tension. Now for minimum tension, we expect the object to be at this point so that the minimum tension on the string is recorded. So that is it for Roman 1. For Roman 2, write an expression for this minimum tension. Now before we write the expression, let's consider this. On this object, we have its weight acting towards the center of the circular path, and its weight is given as mass times gravitational acceleration. And beside that, we also have the tensional force acting on the string, so that by Newton's second law of motion, the centripetal force, which is given as ma, now this is the resultant force, and that is what leads to the centripetal force. Now ma is equal to the sum of these 2 forces, which are acting in the same direction. So we have both of them being positive. So we have tension plus the weight of the object. Now making t the subject here, we have t is equal to centripetal force minus weight of the object. So that from the centripetal force, a here represents centripetal acceleration, which is also given as v squared over r, just as we had seen earlier on. And substituting this in this expression here, we'll say tension is equal to mv squared over r minus mg. Now after this, we can factor out m. Remember, we can even leave our answer at this point, or we can have it as tension is equal to m into v squared over r minus g. So this is the expression for minimum tension on the string. For Roman 3, we are required to use the expression in Roman 2 to determine the velocity v. Now in Roman 2, we had tension as m into v squared over r minus g. Our aim is to get the value of v. Remember, we have the tension on the string, that is 6 newtons, that is for minimum tension. M is 0.4, r is 1, and g is 10 meters per square second. Now doing a substitution, we'll have tension as 6, mass as 0.4 into v squared. Remember, we are looking for v squared over the radius 1 minus 10. Now with this, if we divide both sides by 0.4, we are going to have 6 over 0.4 is equal to v squared minus 10. Remember, v squared over 1 is just v squared. And then taking negative 10 to the other side, we realize v squared becomes 6 over 0.4 plus 10. And for this reason, v squared is 25. If we find the square roots on both sides, v becomes 5 meters per second. And that is the velocity v we are looking for in Roman 3. Lastly, for Roman 4, determine the maximum tension in the string. For maximum tension, we expect the object to be at this position. And when the object is at this position, once again, let's identify forces acting on it. We have its own weight, which is given as mg, and we also have the tensional force acting in that particular direction. And from Newton's second law of motion, the resultant force ma, which is the centripetal force, will be equal to tension minus mg. Now remember, for this case, ma is the centripetal force. Everything that acts towards the center of the circular path, is regarded as positive, and then the other one negative, because it's acting in opposite direction. So centripetal force is equal to tension minus the weight of the object. And from here, if we make t the subject, t becomes ma plus mg. Remember, we can factor out m so that we have t is equal to m into a plus g. Just as we had seen earlier on, a is equal to v squared over r, and therefore our equation will become m into a, which is now v squared over r, plus g. Now, this expression here will enable us to get the maximum tension in the string. We can therefore determine the tension by substituting the values of this. So we have m being, so we have tension is equal to m, which is 0.4, into velocity. Remember, the velocity remains 5, just as we had gotten in part 1. All round, it doesn't matter the position, the velocity will remain the same all through. So that is the linear velocity. It only keeps on changing direction, but the size remains as 5. So 5 squared over the radius, which is 1. And for this case, we are going to add the gravitational acceleration, which is 10. And then from here, if we work out the tension, we realize tension on the string is 14 newtons. That is the maximum tension on the string. And that is how we go about this question. I want to thank you for your patience until this time. Thank you for watching. Hope to see you in the next video. Bye.